Welcome back to Advanced Skills Learning. When people hear that modern large language models support massive context windows, 32,000 tokens, 100,000 tokens, or even more, the reaction is almost always the same. Bigger sounds better. More context must mean smarter answers, deeper reasoning, and fewer mistakes. It feels intuitive, and many teams design systems around this assumption. But in real-world Gen AI systems, that intuition breaks down surprisingly fast. Bigger context windows often introduce new problems instead of solving old ones. In this video, we'll break down what an LLM context window really is, what actually goes inside it, and why simply making it bigger often hurts performance rather than improving it. A context window is the model's short-term working memory for a single request. It represents everything the model can see at once when generating an answer. This includes system instructions, user prompts, conversation history, retrieved documents from RAG, and even tool outputs or intermediate reasoning steps. One important detail is that context is measured in tokens, not words. Tokens can be fragments of words, punctuation, or symbols. This means prompts grow faster than most people expect. A few pages of text, a long chat history, or verbose tool responses can fill a context window very quickly, often without anyone realizing it. Today, context window sizes vary widely. Early production models supported around 8,000 tokens. Modern models commonly support 32,000 or 128,000 tokens. Some specialized models even go beyond that. On paper, this looks like a massive upgrade in capability. But here's the critical question. Just because the model can see more text, does it actually use that text effectively? Quick check, 2 seconds. What mainly fills a context window? A. Model weights. B. Training data. C. Prompts and retrieved text. D. GPU memory. Keep your guess. The answer is C. Prompts and retrieved text. One reason bigger context windows sound appealing is architectural convenience. Teams worry about missing important information, so they include everything, just in case. It feels safer to over-include than to risk leaving something out. Unfortunately, this mindset often backfires. LLMs rely on attention mechanisms to decide which tokens matter most. As the context grows longer, attention becomes more diffuse. Important instructions at the beginning of the prompt receive less focus. Content buried in the middle may barely influence the output at all. This is commonly referred to as the lost in the middle problem. In practice, this means that adding more context can actually reduce answer quality. The model sees more, but understands less. Instead of strengthening reasoning, excessive context often introduces noise that competes with the signal you actually care about. There is also a significant performance cost. Attention mechanisms scale poorly with sequence length. More tokens mean more computation, higher latency, and increased infrastructure or API costs. In production systems, large context windows can quietly become one of the most expensive parts of the pipeline. Another frequent failure mode is instruction loss. System prompts, formatting rules, and safety constraints are often placed at the beginning of the context. When large documents or retrieved chunks are appended afterward, those instructions can lose priority. The model may still respond fluently, but it stops following rules you thought were guaranteed. Quick check, 2 seconds. What's a common failure with huge contexts? A. Faster answers. B. Lower cost. C. Better grounding. D. Ignored instructions. Keep your guess. The answer is D. Ignored instructions. It's also critical to understand what context is not. Context is not memory. It does not persist across requests. Every call to the model starts fresh, and anything you want the model to remember must be explicitly sent again. Long-term state belongs outside the LLM, in databases, vector stores, or application logic, not inside an ever-growing prompt. So what works better? Strong Gen AI systems use smaller, smarter contexts. They retrieve only what is relevant, summarize aggressively, and manage token budgets intentionally. Instead of pushing everything into the context window, they focus on precision. A well-curated 4,000 token prompt often outperforms a noisy 100,000 token prompt. This brings us to the key takeaways. First, bigger context windows do not automatically improve reasoning. They increase capacity, but they also increase noise and dilution. Second, large contexts come with real trade-offs: higher cost, slower responses, and weaker instruction adherence. Third, context should be treated as a scarce resource, not an unlimited bucket. The most reliable Gen AI systems are not the ones with the biggest context windows. They are the ones that control context carefully, retrieve intelligently, and feed the model exactly what it needs, no more and no less. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more Gen AI explainers, practical architectures, and quick quizzes to test your understanding.